So, welcome to the live cast of the Astra launch for today, which is the ElaNa launch. We're here. We're also a group called Astra. We are a student group though, Astra Bremen, and we also share a name with the company Astra. So we thought it would be fitting that maybe we would live stream this launch because we have a particular relationship, just with the name. That's all. We're not even on the same continent. We're in Europe here, and Astra, the company, is based in America. But yeah, they're looking to launch. This is going to be one of their first commercial launches, I believe. They did a test launch back in November, and that was successful. So now this is going to be the first one where they're going to actually be making some money off of the fruits of their labor that has been going on for the past 5 years. So we're really excited to see this launch go up. Obviously, as this is a rocket, it has been delayed a couple times already, so we should keep an eye out for potential delays that could be around. But so far, it's looking really good. We have, I think, about 17 minutes left on the clock. So we're getting near to the point where it's likely that this rocket will actually go up. So that's a good sign. In terms of weather is looking really good. So this is a good sign. It means that we are probably going to be in a good place where we're going to be able to get this launch happening. So that's definitely a good sign. Also, they've looked at some of the reasons for why they were delayed last time. In this case, they were delayed 2 days ago. They had the clock all the way go down to about T-minus 15 minutes. But they were having some issues, I think, there. And then previously in the week, they had it where the clock went all the way down to T-minus 0 seconds. And they still delayed the launch. And this was because they were having an issue with the telemetry. It was a little bit delayed from what they were expecting. And so because of this, they decided to hold the launch and make sure that they check everything and that it's okay. This is one thing about rockets. It's always going to be cheaper to delay your launch than to just try to push through a problem and have that be something that destroys the rocket later on. So anyways, here we are today and looking forward to this launch. But before we get into the details, let's first talk about what the payload is. And this is actually something that's really interesting, is that there are lots of interesting payloads on this rocket that are looking to expand some knowledge in the space area. And because of the vehicle characteristics, the payload that's on this vehicle is actually mostly CubeSats. And these CubeSats have been supplied by some universities in America, and there's also one payload that comes from NASA. So let's talk a little bit about what these payloads are doing and maybe learn about why we need this launch in the first place. So one of the first payloads is called BAMA-1, and this is a satellite that was developed by the University of Alabama, and this is what it looks like right here. It is a satellite that is going to test out a solar sail design, and it's not actually going to use a solar sail for thrust or anything. It's actually going to use it to deorbit. So they're testing a rapid deorbit capability with this solar sail design. So basically what they're going to do is they're going to send this satellite up, it'll deploy from the rocket, and then they're going to go through a process where they extend a big drag sail behind them. And this drag sail will catch some of the molecules that are up that high in the orbit that they're going into, and hopefully deorbit the vehicle relatively quickly. So one thing that's maybe about a bit of a misconception about when you're in space is that it's completely free of any molecules at all. It's a complete vacuum. But actually, when we say when things are in low Earth orbit, it's not really a complete vacuum. There's a little bit of molecules that are floating around up there. And these molecules slow your spacecraft down over time, which is usually a bad thing because usually you don't want your satellite to slow down. You want it to keep its velocity up so it'll stay in orbit. But in this case, when you want to actually deorbit your satellite, it's good to have a little bit of drag. And this is what BAMA-1 is going to be testing, is how do we get our satellites deorbited a little bit quicker. So next up, we have a satellite called Inca. And this is developed by the New Mexico State University, and it is a name. It's standing for a big long title, so I apologize, but it's the Ionospheric Neutron Content Analyzer, and I could not memorize that for the life of me. what does that even mean? Okay, so what it's going to be doing is it's going to be analyzing the neutron density in various latitudes and locations in the orbit that it's going into. And why is that important? Well, it turns out that you can, by analyzing the neutron density, you can actually learn a little bit more about space weather. And this actually relates to the topic of the first mission, which was looking at using air molecules to slow down. In this case, they're going to be trying to look for molecules, specifically neutrons, and that's going to tell them basically about the density of these molecules that are in orbit. And it turns out that this density is always changing, and it's usually changing dependent on what's happening with the sun. So in a way, it's important for satellites to know how dense an orbit will be based on what the solar activity is. And that's what we mean by space weather. So sometimes there could be more density, sometimes there could be less density. And so if you really want to know how much thrust to add or subtract based on where you're orbiting, so you can stay in the same spot, you kind of need to know how much space weather there is to be able to figure out what that density is. So that's what we mean by space weather. It's usually just referring to the density of particles. The other part of it is it's also referring to the radiation environment, because when solar molecules are coming in from the sun, they are usually interacting with Earth's magnetic field, and a lot of the charged particles are creating a charged environment, and they interact with our magnetic field and can create problems for satellites. So that's also what's being looked at with this particular satellite, Inca. But they're not looking at the charged particles; they're just looking at the neutrons. So, yeah. Interesting project there. And then next up, we have a project called CubeSat. And so this is developed by the University of California at Berkeley. And what they're looking at is something that I will probably never truly understand, but it's looking into quantum gyroscopes, which already, as a rocket engineer, that's already scaring me. But basically what this is a potential technology that they could use in order to measure the attitude of a satellite while it's in space. And the idea is that they can use this by using what's called a quantum gyroscope. And this, I don't really know the technical details about what exactly is happening on the inside there, but basically it could be a new way that you could calculate your attitude and potentially do it with a device that's smaller than the ones that we use today and maybe more reliable. So this is also an interesting mission. And then lastly, we have a mission that is coming from NASA itself. And this is going to be, it's called the R5S1. And they're essentially trying to find new ways that they can manufacture CubeSats at a much lower price. And you can already see just by looking at the picture that it's looking a lot more just kind of put together with standard parts. And essentially this should give us a cheaper satellite. So yeah, that's the manifest for the vehicle. Really looking forward to seeing these payloads take flight and what they will contribute to the knowledge of space. So next up, we can talk a little bit about the vehicle. What makes Astra special, I guess, is that they're trying to reduce the cost of access to space. So they're new on the block. They're trying to develop vehicles in a new way. And they're specifically trying to develop vehicles for small satellites. So they're more competing with launchers like Electron and those types of vehicles that are just looking to launch payloads that are less than a ton into orbit. So they wouldn't be competing with companies like SpaceX. SpaceX launches like big rockets with big payloads, and this is not something that Astra is competing in. So they have a capacity with this vehicle of about 630 kilograms into low Earth orbit. So that, again, is similar to the Electron vehicle. I think it has a payload capacity of about 300 kilograms. So they're more or less equivalent in that respect. But what's really different is the cost. So Astra's vehicle has a listing price of about $2.5 million per launch, which is the cheapest rocket in the entire world to date. The only one that comes close to that would be the Electron vehicle, which is developed by Rocket Lab. And they offer a price, I think, of about $5 million, although I think that might have gone up recently. I'd have to check again. But yeah, Astra is definitely the cheapest rocket on the market. So how are they doing that is a good question you might have. And it's actually really interesting because instead of using really fancy materials like other rockets do, like carbon fiber and different types of fancy electronics and things. Astra has taken the strategy of just keep it as simple as possible, just use standard parts, use standard materials like aluminum and steel. Don't go fancy. It's less efficient, but maybe you have to build a bigger rocket, but in the end it actually ends up being cheaper. So that's kind of the idea. You can also see here that they have their own kind of launch pad that they've kind of made. So they're not using one of these big launch pads that NASA uses, that the space shuttle was using. Instead, they've kind of constructed their own little kit here, where they have some carts and they have a filling station and basically concrete, and away you go. I believe this entire setup is entirely mobile as well, so they can basically pack this thing into a container ship and it can go anywhere in the world. So they have a bunch of launch sites. In this case, we're launching from Florida in Kennedy Space Center, but they also have a launch site up in Alaska, and I'm sure they could launch from many other locations as well. What makes their launch location important, though, is basically what orbit you're going into. So for today's launch, the reason why they're launching from the Cape today is because of the inclination of the orbit they want to go into. So they're targeting an inclination of 41 degrees, and basically this would be impossible to go from to do from Alaska. So that's why they have to launch from the Cape. So we have a question here. Do I think the launch will finally go today? Well, I don't really have my crystal ball out right now, but they have been they've been going at this a couple times, and usually it gets a little more promising each time they go. And I think we're down on the clock to, is it like 6 minutes already? Let's check the clock again. 7 minutes. So they have 7 minutes left on the clock. So, I mean, we never really know till it hits zero, but I'm relatively optimistic. It's a beautiful day there. There's no clouds in the sky. The wind looks nice. They have resolved a lot of the telemetry issues. They have passed their spark test. So one thing that's interesting about the Astra vehicle is that they do a spark test before they actually launch. So they do a bunch of these little tests leading up to the launch. So usually if you get past about T-minus 15 minutes, it's usually a good probability that there could be a launch today. So I'm hopeful. Yeah, let's talk a bit more about the vehicle and what makes it special. So I talked about how they're using more standardized materials, just aluminum and steel and stuff. They also have a pretty basic setup when it comes to the engines that they have. They're just running on liquid oxygen and kerosene, which is pretty standard throughout the industry. They're not using any fancy fuels, so they get reasonable specific impulse, which is the efficiency of the vehicle. In terms of complexity, one thing that is difficult for liquid engines is trying to develop a system that is reliable but without being too complicated. And Astra has chosen that instead of using complicated turbo pump machinery, which is common for the bigger rockets, they're just using an electric pump-fed engine. So this means they can just basically strip out all that complicated machinery and just go straight to just having a electric motor basically drive the pumps that pump the fuel into the combustion chamber. And you do pay a mass penalty for this because batteries are really, really heavy, but it tends to be way simpler to build, and the system is usually cheaper in the end, even though you have to build bigger, right? But bigger is not always bad. Sometimes bigger can be cheaper. The upper stage of the rocket, so there's always two stages of the rocket if you want to go to orbit. So we were just talking about the lower stage. The upper stage of the rocket, which is going to be just the top little piece there that you saw, that is powered by a pressure-fed engine. So this means that they just have pressure vessels for the fuel of the rocket, and that pressure is what pushes that fuel into the combustion chamber. And that's also a really simple system, even simpler than the electric pump-fed system. So Astra has really tried to keep it bare bones and keep their system as simple as possible in order to bring down the cost. So yeah, that's a goal that is, I think, commendable, and it's definitely a goal that we share here at the student group Astra. We are trying to build a rocket that's going to go to the carbon line, and of course, in order to do that, you obviously have to keep your costs down because we're a student group. We don't have any big funding, and we don't have any profit motive or anything. So, yeah, we're definitely having that same philosophy. So yeah, let's listen in to see what's going on here. We're getting close to the launch time now, so I'm just gonna switch over to their audio.
Control room, if you require RF data in flight, be prepared to switch over your pages. MIFCO, flight on countdown. MIFCO, prepare to issue option when rocket IIP marker passes min-MECO point and is within dispersed trajectories, calling out at event.
MIFCO copies.
One thing to look out for is what's happening for the launch. So basically, we're going to go through a couple of phases here. Obviously, we're going to have the launch happening at T-0, and then the vehicle is going to start going up. That first stage is going to burn for about 3 minutes, and then it'll get going to about a quarter of the velocity that it needs in order to get to orbit. But then it's going to separate from the vehicle, and it's going to allow the second stage to ignite its engine, and it will continue on to orbit. This is a little bit different than maybe you might be used to with launches like SpaceX. Obviously, the Astra vehicle is not going to be reusable. Again, part of their keep it simple philosophy. They've stripped it down to the bare bones. So there's not going to be a recovery of the booster or anything like you would see in a SpaceX launch. And yeah, another interesting thing, I guess, would be these vapor clouds that are coming off the vehicle. It's not that the vehicle is smoking or anything. This is normal. It's just the liquid oxygen that is being constantly fed into the rocket. As you come up closer to the launch time, you want to make sure that the vehicle is always fully fueled. And the problem with liquid oxygen is that it's really cold, so the heat from just the outside starts to heat it up a little bit, and then it starts to boil off out of the tank. So you have to constantly be fueling it, and some of it is constantly coming out. And when it comes out, it's really cold, and it causes a bunch of the water in the air to condense, and that's why you see these vapor clouds. But yeah, here we go. We're down to the last minute. My heart's racing a little bit. I hope this one works.
PSD recordings enabled.
45, first stage coming up to liftoff pressures. Tanks are pressurized at this time. 30 seconds.
Everything's looking good.
20.
So far, no issues.
15. 10, 9, 8, 7, 6, 5, 4, 3, 2, 0.
Ah, here we go. There it goes. How about that?
LV0008 has launched and is on its way to space. You can follow the flight milestones on the left side of your...
I was a little bit nervous there when it didn't start taking off for a couple seconds after T-0. I thought it might have halted again, but nope, it was away it went. One thing you might have been interested by was the water funnels that came shooting off of the base of the rocket at T-minus 5 seconds or so. That's called the water deluge system, and the reason why they do that is to help dampen out the sound vibrations that are caused by igniting the rocket engine. But yeah, everything's looking pretty smooth right now for the launch. not as quite a good a tracking camera as the SpaceX tracking camera, but all is okay, I guess. So the vehicle just has passed through what's called max Q. That's the time when it sees the maximum aerodynamic pressure. And it happens just after usually the vehicle passes through the sound barrier.
All systems on the vehicle are nominal, and we are tracking it downrange. We'll be looking for MECO, or main engine cutoff, at T plus 2 minutes and 50 seconds. Clear skies have provided a great view of LV0008 so far.
So we'll be coming up on MECO at about T plus 2 minutes and 50 seconds. So I don't know if we'll see the onboard camera at that point, because you can just barely see the launch vehicle right now.
Flight, MIFCO, option sent.
Copy.
FTS confirms option detected.
Safety can't confirm.
That call out of the option means that the system will safely be able to ignite the upper stage after
MECO.
our stage separation. And that was MECO, or main engine cutoff. That was fairing separation and stage separation. And you can see that the upper stage ether
is
engine
running.
has lit.
I don't know. It looks like we might have a problem here because the vehicle is spinning. I think they're having a problem with stabilization. Although maybe I am... You'll have to listen in to see if this is nominal or not.
Opening OV202.
Yeah, when the vehicle is spinning like that, that's not looking nominal, I would say. So I think this might have been a launch failure. But don't put me on the record. It could have been that the camera was just on the booster stage or something and I didn't realize it.
And it looks like we've lost video of the upper stage and standing by for more information.
Yeah, so they definitely lost video. So I think that what we have here is that we had the vehicle, the upper stage vehicle. I think they had an issue with control, so they couldn't control the attitude. So basically, when they lit that rocket, it just started spinning and spinning and spinning and spinning. And obviously, you can't get to orbit when you do that. So I think this is going to be a launch failure, and it's most likely because of the attitude control issue with the upper stage. Yeah, orbit's hard, guys. Rockets aren't easy. Yeah, if we get a confirmation soon here, maybe we'll go back in the stream and see what exactly that looked like. But first, let's wait and see if we get a real confirmation of what happened. So yeah, Taha is saying that it might have got stuck on separation and lit the second stage before it physically separated. Yeah, that would be a problem if they did that, because then they would have definitely damaged something for sure. Maybe we can, yeah, let's go back and see if that's actually what happened. Now I'm curious. So where are we here? Sorry guys. So right around here is when we saw the footage.
Copy.
FTS confirms option detected.
Safety can't confirm.
Okay, so let's look right now. Let's see what happens. So main engine cuts off, and then see that separation. It didn't quite go, and then yeah, that's what it looks like. What happened? I think you're right, Taha. Let's go back. Okay, so you see here, there was a separation event. There was like a shutter, and then there, see it? But it doesn't quite separate. So that engine was clearly lit already and basically pushed off the booster stage. And so it probably ripped something off and it put it into an uncontrollable spin. So it could be that there was nothing actually wrong with the attitude control system or the engine at all. It could have just been that the engine was lit while the booster stage was attached and actually physically destroyed the connection with the booster and probably nicked the second stage and put it into this uncontrollable spin. That is my theory. We'll see if the theory's right. So I guess we'll have to stay tuned with the news on this one. Okay, we switch back to the live. See if they're saying anything. Yeah, the separation systems on rockets are, I would say, somewhat of an undervalued system. Maybe not the most exciting part of rocketry, but if
We're still waiting for more information on the LV0008 mission. Right now you're seeing a view of our pad at Cape Canaveral, where the team is securing the area.
Yeah, like I was saying before, the separation system is, I would say, an undervalued system. If you don't have a good separation, it's really hard to recover. Obviously, as you can see here, getting it to be reliable and working all the time can be always a challenge. And there's also the added challenge that when you perform the separation, obviously you're usually over 100 kilometers above the Earth, and it's basically a vacuum, and you're in a weightless environment when you perform that action. So it's really hard to test to make it so it's exactly like the conditions that you'll see on the launch. So it's a lot of guessing and trying to find tests that will replicate the conditions of your separation, but you never get really the true exactly the same scenario until you actually physically go and launch. So it can be challenging to really verify and validate a separation system. So for all you Astra recovery engineers, take note. I was referring to the student group Astra in that case. All right. Are there any other theories from the stream about what might have happened, or are we in agreement that it was probably caused because of the ineffective separation and ignition of the engine while the booster was still attached? That's what my buddy's going to be on. I think Taha's correct. Yeah, it's really too bad. These four CubeSats that were on the payload would have been really interesting missions to have. So yeah, there's definitely some some students and professors and engineers at these 3 universities, at the University of Alabama, New Mexico State University, and University of California, that are probably pretty disappointed right now. Yeah, it definitely sucks to see the work that you've put into something for a couple years, end up as not really working out in the end. But yeah, this is the march of science, though, right? You have to try things out until before you can make them reliable. Someone's got to be the guinea pig. Someone's got to be the first try. Yeah, I'm sure that Astra will get this figured out eventually. If you look back at the success rate of rockets throughout history, like just like when they were in development and stuff, like even just SpaceX or like the Atlas rockets, or even like the Soyuz and or the original like the Delta rockets from back in like the 60s and the 70s and stuff, like their launch records were like atrocious. Like they would lose like 1 in every 4 vehicles. So it takes a while to develop a program that is fully reliable.
And thank you for standing by with us. Unfortunately, we heard that an issue has been experienced during flight that prevented the delivery of our customer payloads to orbit today. We are deeply sorry to our customers, NASA, the University of Alabama, the University of New Mexico, and the University of California, Berkeley. More information will be provided as we complete a data review, and you can follow along for updates on Twitter at Astra, as well as on our website, astra.com.
Yeah, everyone, thank you for tuning in for today's live coverage, and thank you to Astra for partnering with NASA Spaceflight and allowing us to broadcast this launch to everybody. And again, stay tuned for further updates from Astra and from NASA Spaceflight. But thank you all so much for watching, and stay tuned for more information. But we'll see you later. Thanks, everybody.
All right, so that's it for the confirmation. So it's confirmed now, 100%, that the payloads were lost, and the vehicle did not make it to orbit. So definitely stay tuned for the details of what happened and why this went the way that it did. And obviously, if you know anybody who worked on these projects, just be there for them. It's really tough to see all of this. It's really tough to see all of your work end up not going to space. But yeah, in terms of Astra running out of money, I wouldn't say that's going to happen just yet. They got a whole factory going. Like they're pumping out these rockets on an assembly line basis. So obviously they'll have to investigate what exactly happened wrong here with the separation system, it looks like. So that'll take some time for the engineering team to do some failure analysis, obviously. And hopefully it's not like a huge problem that's going to totally block up their entire production. But there'll be an investigation for sure. I don't think they're going to run out of money, though. They have, I would say Astra is like one of the most funded small sat launcher in the world, nearly. Like they really have like billions of dollars at their disposal. So obviously a lot of that is investor money. So, obviously the investors could lose confidence. But yeah, I wouldn't say that it's the end yet. If the investors lose confidence after one failure, I would say that they didn't know what they were getting into in the first place. What's the first rule of rocketry? Always assume it will explode. Yeah. So yeah, I hope the investors are not too skittish, and they will stick through until Astra gets this rocket going relatively reliably. The good news is that the first stage went flawlessly. They had a picture-perfect first stage launch all the way up to MECO. It's just the stuff that happened after that that didn't end up going so well. So the expensive part of the rocket worked. Yeah. So yeah, I'm sorry to all the Astra fans, but I'm sure that they're gonna figure this out in the end. So you just gotta, yeah, being a rocket fan is always hard because the failures come. Anyways, I think we're gonna leave it there. Stay tuned to see what the news is on what happened with the rocket. It'll definitely be a failure that'll be interesting to talk about. And yeah, if we hear about what's happening, we might make a video about it maybe, because it could be an interesting failure analysis. And I'll look into what failure analysis really is, because it takes a little bit of a investigation, and you got to look more than just look at the video and be like, that's what looks like what happened. So of course we can all sit here and pretend to be expert engineers that we know what went wrong, but of course you need to look at the data and really see what happened. So we have a question on when the next launch is scheduled for, and I think I have that. Let me just check. Where did I have that? So I think they have a launch actually scheduled for the 28th of February. But I highly doubt that they will actually keep that date, because usually when you do these, when you have a failure like that, the investigation takes usually a month or two before they're ready and comfortable to just go out to the launch pad again. Obviously, they don't want to have the repeat of the same error. So if they send out the exact same launch vehicle up to the pad, what's the definition of insanity? Doing the same thing and expecting different results, right? So although they do have a launch scheduled for February 28th, I highly suspect that they will probably delay that. And if I were a customer aboard that rocket, I would be like, yeah, please don't launch me so soon. Maybe figure out what happened first before you launch my my $1 million satellite. But yeah. All right. So yeah, maybe we'll definitely do a video about maybe what happened after they released the analysis, and then we'll probably stream the next Astra launch when they come. So we'll have to see what happens there. I hope they're back to the launch pad quick, because I'm really excited to see this rocket launch some more. It definitely has some really good implications for spaceflight. Anyways, that's it for the Astra livecast today. Thanks for tuning in, and we hope to see you in the future. And remember to keep expanding your horizons.